Today I'm going to be going over how the function y is equal to cos x is translated and dilated into the function y is equal to 4 cosine x on 2 plus 1, the first of which is the period. The period is known as the horizontal translation. We can easily find what the period is through a simple method of first taking the formula y is equal to cos x, where the period is 2 pi over a, and substituting in the values from the function into the formula. A is equal to a half. If we substitute this into the formula, we get 2 pi on 0.5, which can be simplified to 4 pi. Hence, the period is 4 pi. The next is center. Center is the vertical translation, and in the formula y is equal to cosine x plus c, c is the center. If c is larger than 0, then the center is translated up, and if c is smaller than 0, then the center is translated down. And because the center is positive, this means that it is being vertically translated 1 unit up. The next is phase, or in other words, phase shift, and this is a horizontal translation. The phase shift formula is y equals cosine x plus b, where b is essentially the phase shift. If b is larger than 0, then the phase shift goes left, and if b is less than 0, the phase shift goes right. But in our example, there is no b, which means that there is no phase shift, and the function neither shifts left or right. And last but not least is the amplitude, which is the vertical dilation. In the formula, y is equal to k cosine x. K is the amplitude. Therefore, the amplitude is 4. It's important to figure out if the domain or the range have been impacted in any way. First, we can start off with figuring out if the domain has been impacted. The original domain of the function is negative infinity to positive infinity. Now, the domain is only impacted by horizontal translations or dilations, and there is only one in our example, which is x over 2. Now we can try and apply x over 2 into the domain by timesing both sides by 2, but this doesn't impact the domain, as they are both infinity, and timesing any number by infinity does not impact it. Next is the range. The range of y is equal to cos x is -1 is smaller than or equal to y, which is smaller than or equal to 1. But unlike the domain, the range changes due to the vertical translations and transformations. Firstly, we're going to do the vertical dilation in y is equal to 4 cos x on 2 plus 1. The vertical dilation, or in other words the amplitude, is the 4 in the front. This means we time the maximum and the minimum by 4, which means the new range is -4 is smaller than or equal to y, which is smaller than or equal to 4. But it's not done yet because we need to do one more translation, this one being the center, which is shifting the entire function up by 1 unit. -4 becomes -3, and 4 becomes 5. So the new and final range is -3 is smaller than or equal to y, which is smaller than or equal to 5. Now the question asks us to draw y is equal to 4 cos x on 2 plus 1 in the domain of 0 to 2 pi. Firstly, I'm going to start off with the horizontal dilation, which in other words is known as the period. We know already that the period is 4 pi. This means we're going to be stretching our function horizontally along the x-axis. Next, we're going to do the vertical dilation, which is the amplitude. All the y units are timesed by now 4, meaning the starting point of 1 now becomes 4, and the ending point of -1 now becomes -4. But wait, there's still one more translation to go, which is the center, where we shift the entire function up by 1 unit. This changes the maximum from 4 to 5 and the minimum from -4 to -3. The final thing to do is to plot all the intercepts and important points on our graph. The y-intercept is 0, 5, and the ending point at 2 pi is 2 pi -3. But before we finish, we still need to label one more point, which is the x-intercept. But how are we going to figure this out? Well, we start off with our function y is equal to cos x on 2 plus 1, and we let y equal 0. So now it's 0 equals 4 cosine x on 2 plus 1. Firstly, we minus 1 from both sides. Then we divide both sides by 4. Then we invert both sides by cos, which means we end up with the left side being inverse cos negative 1 on 4 is equal to x on 2. Finally, we times both sides by 2, and we get what the x-intercept is. And we can round this to 2 decimal places. Now we have accurately found the center, period, phase shift amplitude, domain, range, and accurately sketched out the graph with all the intercepts labelled correctly. I hope you found this explanation helpful when transforming y is equal to cosine x to y is equal to 4 cosine x on 2 plus 1, both visually and mathematically. Thank you!